Dr. Joseph Matthews, welcome to Physiologically Speaking. Could you briefly introduce listeners to who you are and what you're doing, and also tell them, currently how much protein you're eating per day?
So I will start on the protein question because that's an easy one. So I'm about 100 kilos, so I eat about 1.5 grams per kilo of body weight. So I'm about bottom end on a lower day would be around 150 grams of protein, and sometimes a bit above that. I'm a physiologist and nutritionist, currently researcher at the University of Arkansas for Medical Sciences, where I'm doing my postdoc. Been in the US just over a year now. In the UK, I'd done several different roles, science and research, but I'd also been practicing as a nutritionist for just over a decade with anywhere from recreational to elite athletes. So I like to have my foot in the research side, the science side, the practice side, and kind of doing all of those to an okay level, probably none of them perfectly.
Well, I think it's good that you have kind of your feet in both because, not that there's anything wrong with just being in academics, but sometimes, I think it helps to maybe have the practical side, especially when you're talking about something that we're going to talk about today, like protein that is applicable to athletes, applicable to people exercising, aging, and things like that. So I think that provides you with a unique perspective. So the reason I invited you to chat with me today was because you just authored this review that I read, really enjoyed. It's titled Understanding Dietary Protein Quality, Dietary Indispensable Amino Acid Score, and Beyond. And essentially, what you tried to do in it is redefine maybe how we should think about protein quality, talk about some of the limitations with how we define it. And why I enjoyed it was because I think we have, maybe for good reason, but a hyperfixation kind of in the health space lately on protein, which I don't think it's necessarily a bad thing, but we're becoming a bit obsessed with it in terms of making sure everybody's getting enough. And I think you have probably seen this as well, maybe especially now being in the US, but everything seems to have protein in it these days, even chips or if you go into the store, cereal, everything is just loaded with protein. It's kind of this macronutrient that everybody is interested in, primarily just getting enough in terms of protein quantity. But this review that you wrote doesn't really talk about that at all, really, in terms of should people get enough, but what does it mean to eat a high quality protein, and what really even defines a protein quality, and why should we even think about protein quality as being meaningful? So to start off, just can you define what protein quality is for listeners?
Yeah, sure. The conventional definition currently set by the FAO is it's based on the ability of a protein source to provide bioavailable essential amino acids. So the dietary protein we eat is made up of 20 different amino acids. 9 of those are essential. The body can't make them in sufficient amounts. And the proportion of essential amino acids to non-essential amino acids that a food contains differs across different types of food and food groups as well. So it's really about, if you've got a protein source that says 10 grams of protein, A, how well is that digested and how much do you absorb? And B, how much of that comes from the essential amino acids? And the idea behind the current protein quality definition is that a food that provides more of those digestible or bioavailable essential amino acids is higher quality. Another way to think of it, because the term quality can make it sound like that food is automatically better, and that's not necessarily the case because we eat whole diets and there's a lot more nuance and context around that. But another way to think of how we define protein quality is that it's a measure of essential amino acid sufficiency, so the ability of that food to provide those essential amino acids.
Right. And what are the two ways in your review? You mentioned kind of two of the main ways that protein quality is currently measured. Can you describe what those are and sort of how they're used and what they are in plain terms?
Yeah, so the two chemical scores are the most common, but there's lots of different methods that can be used to indicate protein quality. But there's two chemical scores. The traditional one is called the PD-CAS, which is the protein digestibility corrected amino acid score. So that takes the amino acids contained in a food and corrects them for how much you lose to digestion. And that corrects them based on an overall digestion value for the food. So you've got those 9 essential amino acids. Let's say the protein digestibility of that food is 80%. So you would correct those amounts down to 80% of their value would be the PD-CAS score. The newer chemical score is a similar principle. It's called the DIAS, the digestible indispensable amino acid score. The difference of the DIAS to the PD-CAS is that the DIAS measures the individual digestibility of each essential amino acid rather than having a total digestibility value for the protein. It measures the specific amino acid digestibility, and that those measurements give us something called true ileal digestibility. And those measurements are normally made in pigs. It can be made in humans, but the way the method's done, they're measured in pigs. So they would, for the dias, they feed the food, and then they will take a sample from the distal ileum at the end of the small intestine, and whatever is remaining at that point has not been absorbed, and that's used as the marker of digestibility. How we go from those values to a score is that, and this is where it gets a little bit complicated. So you have the dietary reference intakes for each essential amino acid. So that's 9 separate values. Now, how well the food meets the requirement for each individual essential amino acid after it's been corrected for digestibility, you will then have a score. Say for leucine, your score might be 1.2, meaning that that food provides 20% more than the dietary reference intake for leucine. But for another amino acid, it might be 0.8, meaning it provides less than the dietary reference intake. So what happens is you have an individual score for each of those essential amino acids for the food, and the lowest score is taken as the DIAS score. And the same principle as the PDCAS, the lowest score is taken as the PDCAS. So it's based on the concept of, if you ate this food, what food does this, in this food, which essential amino acid does it provide the least of relative to the dietary reference intakes? And then that is used as the rate limiting amino acid. So if you see a DIAS score of 0.8 or 80%, sometimes expressed as a percentage, it means that that food is limited by an essential amino acid that only provides 80% of the daily amount.
Okay, interesting. And so the DIAAS, though, it seems like it would be a bit of an improvement then over the PDCAS because, and correct me if I'm wrong, but so the PDCAS seems like it was just an overall estimation of, I guess, the amino acids, where the DIAAS, it corrected for each amino acid, and the PDCAS doesn't do that. Is that right? So is it supposed to be a little bit of an improvement because you're looking at each of those individual amino acids by themselves versus a whole score across all of the amino acids?
Yeah, that's right. So that's one of the key differences. The other key difference is the PDCAS scores are truncated at 1 or 100%. Meaning that a lot of foods have a protein quality rating of 1 or 100%. You can use either values. If it's a decimal, it's 1. If it's a percentage, 100%, meaning that it meets the requirements for all of those essential amino acids. Foods could provide well above that level, and you wouldn't know because they're all truncated to the ceiling of 100%. Whereas with the DIAS, they're not truncated. If you take a casein protein supplement, which has one of the highest DIAS scores, that's going to have a score of about 140%. So it shows you that it provides well in excess of those essential amino acid requirements. So that's another key difference between the two.
Yeah, I mean, I think that's great because if you truncate it at 100, it's like you have I don't know, just to use an example, whey protein, and then you maybe have like a chickpea, and then you have like a whole steak. So all of those could be, and maybe this is not actually correct in practice, but all of those could have a score of 1, but obviously maybe whey protein is much better, but you wouldn't be able to tell based on the PDCAS which one was actually better.
Yeah, that's right. It's just taken as a given, and once you max out that score, it's considered a high quality protein. Some of the plant-based proteins will have scores around, say, 0.7 or 0.8, showing that they are rank lower. But the nice thing about not truncating the score is it means you can see, this food provides a lot more, this food provides a lot less. You combine those two in a diet or in a meal. It gives you an easier way to see how to combine foods to get to that protein sufficiency or essential amino acid sufficiency.
Totally, which is something I think a lot of people probably aren't doing, in part because probably it's information that's not readily available, or people probably don't know to find it. It's not really on a food packaging, and maybe that's something we can talk about a little bit later. But regarding the current ways that we define the protein quality based on these two chemical scores, what do you think, why is it important to sort of redefine it? What do you think are some of the limitations of using these chemical scores, and why might they be misleading perhaps for health perspective, or misleading in terms of just telling us about what a high quality protein is?
Yeah, sure. So the biggest limitation is not necessarily the problem with the method themselves. It's the scoring systems they use. So I said that the the score for each essential amino acid is based on how well it meets the dietary requirements. They're based on the dietary requirements for each essential amino acid intake. And it might be that the profile of those essential amino acid requirements or the total amounts are actually not what are sufficient for human health and performance. So the score will always be limited by the underpinning dietary guidelines, which there's several question marks over if they are appropriate. And work from our group and collaborators of our group suggest they need to be substantially higher, but also the profile of them would be slightly different as well. And because they're based on those dietary guidelines, they're not based on a metabolic effect or outcome. And one of the main reasons of eating dietary protein is to promote protein synthesis, both whole body in all organs across the body, but for most active people in skeletal muscle. And these current scores don't relate to any of those metabolic outcomes, or they weren't designed to predict a metabolic outcome. It's not necessarily a problem with the score. It's just not how they were devised. So if your interest is in maximizing the muscle anabolic response to a food intake, the current chemical scores might be ranked in a way that is going to lead you to better sources, but they haven't actually been validated against that.
Okay. We're definitely going to talk about the muscle protein synthesis stimulating effects. I do want to back up slightly, though, because even though we're discussing protein quality, I think that it's important to discuss the estimated average requirements and the RDAs. So can you just tell people, and let's go with perhaps maybe the RDA for protein, and you can add something there if you think is necessary. But what's the current RDA for protein? Most people, I think, at least in the health space, are currently, at least one thing that people in health space can all agree on these days is the RDA, as it's defined, is currently like way too low for protein. But just tell people what the current RDA is, and then you mentioned how you and some of your collaborators propose that it should be probably much higher than it is. So could you discuss that a little bit?
Yeah, so the current RDA is based on body weight. So it's 0.83 grams of protein per kilogram of body weight. So if you take a 80 kilo person, then the requirement's going to be about 65, 66 grams. But that's based on nitrogen balance studies, which are several decades old now, but that would be the minimal amount to maintain nitrogen balance in the body. And that RDA is designed to be sufficient for 98% of the population. It's not designed to maximize adaptation. It's not based on maximizing any health outcome. It's just avoiding a negative nitrogen balance. So I think what's generally accepted is you would see that as the minimum requirement for most adults, but that's a very contentious issue, and what that amount should be is a big question mark, and it's going to depend on the age, population, your activity levels, the type of training you're doing, are all going to play a factor on how much protein you probably need beyond that 0.83.
What do you think it should be? Maybe I'm sure you have an evidence-based opinion, but in your opinion, what do you think that, and let's not call it the RDA, but like, what do you think the minimum amount of protein really for health/performance should probably be for most people?
I'll give you three specific people I'd aim that at. So if you take someone sedentary, take somebody who's not engaged in activity, maybe someone who's an older adult or isn't doing any structured training, then probably around 1 to 1.2 grams per kilo is probably sufficient. Somebody who's doing some mixed training, maybe some aerobic training, you've got the next band would be sort of 1.2 to 1.6. And if you're doing heavy resistance training at the 1.6 and beyond, you get to the level of the serious bros who are really crushing it in the gym, then up towards the 2 grams per kilo. I still think that they're pretty standard benchmarks, and I see no reason I don't think we have strong evidence to suggest anything outside of those at the moment. Although I think if your protein intake is at the bottom end, then quality becomes more important, which is probably one of the things we'll get into.
Yes, definitely we will. It's interesting. There's so much, I guess, argument on. I think everybody agrees that it should be, more. I think protein is probably better up to a point, but then you get the 1 gram per pound of body weight folks, which would be, 2.2 grams per kilo, which some people argue is excessive. I think the unique thing about protein is that I guess there doesn't really seem to be a downside to consuming more of it. I think there's definitely a downside to consuming an excess of carbs and probably an excess of fat. But with regards to protein, it's like eating more doesn't seem to maybe like have all these downsides. And I feel like that's the reason for this current protein push. But I think what you said is pretty sensible. I would tend to agree. And even endurance athletes, though, I think, could maybe be eating as much protein as, say, like a bodybuilder or somebody trying to build muscle. I think if you're doing a lot of, cycling, a lot of running or something like that. I mean, I probably almost eat 2.2 grams per kilo. Granted, I only weigh about 68 kilos, but still, it's a little bit easier for me to eat that much protein.
Yeah, and on the point of no downside, I think back to when I was doing more work with athletes, the downside would be if chasing that protein amount comes at the expense of displacing other nutrients. And
yeah, that's a great point.
And if the focus is so much on consuming protein that it means somebody's underfueling carbohydrates, then I think you've got an argument there that the performance will probably be improved by having some more carbohydrates at the expense of the protein. But for most average people out in the world doing recreational exercise, they're not consuming to the excessive amounts that could cause that. Not from my general practice anyway.
Yeah, at least a downside from some sort of like negative metabolic effect. I do think the point you brought up about the endurance athletes was a good point, though, because I've actually thought about this for myself lately in terms of fueling my training, where I tend to be kind of hyper-focused sometimes on protein at every meal, and I'm thinking, oh, well, I could probably eat a little bit less protein. I'm still getting, 150 grams per day, but maybe replace some of the protein on my plate with carbs, because, yeah, if you are eating so much protein at the expense of carbs, then you could, at those higher levels of training and performance, maybe compromise your performance, your output, and things like that. So definitely a good point there. So I want to move on to now, you kind of talked about what the limitations of the current chemical scoring methods are. Now let's talk about what actually determines protein quality, or what maybe different measures we can use to define a protein quality. And you sort of mention four rather in this review: amino acid density, digestibility, bioavailability, and stimulating protein synthesis. So maybe we could start with digestibility. And could you define what that is, why that influences, and how that influences the quality of a protein?
Yeah, so digestibility is basically from the food on your plate or in your hand, what proportion of that protein is actually going to leave the intestine and enter the body. Now, for most, and this is a tricky thing talking about protein, is it's not about plant versus animals, but I will use that comparison just because there are some distinctions that make that easier to describe. So for most animal-derived proteins, so dairy, eggs, meats, poultry, seafood, the digestibility is going to be really high, normally 90% or above. It's pretty standard. The only thing that would change that would be if it was really overcooked in a way that you get to a point where you've overcooked at high temperatures, it actually reduces digestibility. But for the most part, digestibility is going to be really high. For plant-based sources, they're normally on the lower end, but you can increase that digestibility with certain processing and cooking methods. And one point we make in the review is actually a lot of the plant-based meat alternatives, so things like the plant-based burgers now, they're processed in such a way that they tend to have quite high digestibility. So you take like an Impossible Burger, it's got digestibility of around 90%, which is comparable to some animal products. So what that means is if that burger says 20 grams of protein, then 90% digestibility means 18 grams of that is entering the body, or there's 2 grams that doesn't enter the body. Yeah, I think that maths was right. That's right. Bioavailability is then and there are a few different ways to define this, but bioavailability is the proportion of amino acids that make it into the systemic circulation. So a large proportion of what you eat will be taken up by the splanchnic tissues and used for a turnover of intestinal tissues or liver, for example. And based on some of the research that's used labeled proteins, it seems to be that anywhere between 45, 55, maybe 60% of the amino acids that we eat get to the systemic circulation. So that means you can actually measure them in the bloodstream. The rest is lost to digestion or turnover of those splanchnic tissues, which is still part of whole body protein synthesis. That's still a positive thing. So if we move from digestibility to bioavailability to then protein synthesis, we've got whole body protein synthesis, but we've also got skeletal muscle protein synthesis, which when we're talking about performance or aesthetics, we're normally interested in muscle protein synthesis. So you've got about 45% to 55% of those amino acids making it into the bloodstream where they can even influence the muscle. And then you have a smaller proportion that actually make it into the muscle and are synthesized into new proteins. And at the moment, the current protein quality metrics don't assess that last piece, which is how well does this food stimulate muscle protein synthesis. But we can measure that in the lab. And one of the sections in the review was talking about the qualities of a food that are also important for driving that protein synthesis. When we start thinking about recovery and performance, that's probably an outcome we're interested in. But it's not captured in the current protein quality scores. And a good example of that would be comparing a beef burger to a soy-based burger. They would have similar protein quality scores, normally around 90 to 95%, but they would have different effects on muscle protein synthesis. So there's a slight inconsistency in a protein quality score versus the metabolic effects of that protein.
And I want to maybe talk about digestibility and bioavailability in a bit, but since we're on the topic of stimulating muscle protein synthesis and you use the example of a beef steak versus the soy burger, plant-based meat alternative, something like that. So you noted similar protein score regarding protein quality, different ability to stimulate muscle protein synthesis. So why is that? Does that have to do with the types of amino acids in those proteins?
Yeah, it's probably a few different factors. So the protein quality score is just based on the limiting amino acid. It might be that food provides other important essential amino acids in far greater excess. So if you were comparing a beef to a plant-based alternative burger, the beef burger is going to have slightly higher total essential amino acids. So there's more substrate there for the muscle for protein synthesis. It's also going to be slightly higher in leucine as well, which is fairly important for stimulating that muscle protein synthesis response. And it might also be related to the absorption kinetics. If a food is absorbed slightly faster and creates a higher peak in the plasma essential amino acid concentrations, that seems to be quite an important determinant for driving protein synthesis. And my colleague and the director of our research center, Dr. David Church, has done a fair bit of work on that.
Yeah, David, when I used to do a different podcast and I actually interviewed David Church about one of his review articles several years ago. So I know he's doing a lot of cool work there. Yeah, you brought up leucine, and I know leucine is sort of a very important amino acid. Sometimes people talk about it as being the most important amino acid as stimulating muscle protein synthesis. Is sort of this leucine, I think the leucine trigger hypothesis, is that still sort of in vogue in terms of is that still considered to be correct regarding, this is sort of the rate limiter, leucine, you have to eat that to sort of start the muscle protein synthetic machinery, and then all these other, obviously, amino acids are necessary for that. Is that still kind of considered to be the main line of thinking and the main ways that one of the reasons why high leucine protein sources can stimulate muscle protein synthesis and are considered to be higher quality?
Yeah, yes and no. So the idea of a specific trigger in terms of an amount or a threshold in the blood is much more fuzzy and vague. So the term leucine trigger hypothesis is used a lot less now. So I'd separate the concept of that trigger from the fact that leucine is an important essential amino acid for stimulating protein synthesis. And there's been some nice work on this looking at from Stu Phillips' lab, where they compare a plant-based blend protein drink, like a protein isolate, and the plant-based products tend to be a little bit lower in leucine. So they'll compare the plant-based blend to a whey protein drink, I think in the study I'm thinking of. And then they also had a third group that had the plant-based drink and topped up with a bit of extra leucine. And you see that if you just compare the plant-based drink to the whey, that the whey slightly outperforms it for driving muscle protein synthesis. But if you top up the leucine content of the plant drink, then it is equivalent to the whey. So it seems to be there that just by eating sufficient amount that you get enough leucine seems to maximize the response. What that exact amount is not completely clear, because there's been some other studies where they'll just give a really low dose of leucine and you see a large muscle protein synthesis response. So there's a few different groups still sort of working and trying to tease out if there's a specific amount of leucine or exactly what that factor is. But I think most people across the field, I can't speak for everyone, but I think most people would be in agreement that leucine is one of the important essential amino acids, but you need all of the essentials there to to drive synthesis and sustain synthesis as well.
Definitely makes sense. Okay, so the capacity to stimulate muscle protein synthesis, one of the defining qualities of a high quality protein. Can we just maybe review what influences its capacities? Kind of amino acid composition is one of them. What are the other factors that influence a protein's ability to stimulate MPS? I know whole body protein synthesis is also a thing that's clearly important, and I do always find it interesting too when people talk about protein synthesis. It's typically just muscle protein synthesis, but as you mentioned earlier, it's like, well, we're making, mitochondrial proteins. We're making all these different proteins throughout the body that are like necessary, and so there's more than just muscle protein synthesis. But when it comes to health and performance, kind of, obviously MPS is the main thing people are worried about.
Yeah, no. I'd just add as well that the turnover of muscle protein is very slow, and it's a very large pool of proteins to turn over. But from the body's perspective, it's not the highest priority. All of the other organs are. So the other organs turn over at a rate several-fold the rate of muscle. And if needed, the dietary proteins will be used for those other organs and processes before they're used for muscle. And we can actually see it. I'll come back to the protein synthesis question from diet, but to really drive that synthesis into muscle, that's why exercise is so important, because without the exercise stimulus, those proteins will be used for whole body protein synthesis in other areas. If we're looking at a food source of what really drives the muscle protein turnover, it's going to be the essential amino acid content. If it's a high quality protein source, it's going to contain leucine anyway. And then just the digestibility and the ability of that food source to raise blood amino acid levels. And there's a couple of nice studies. There's one that Dr. David Church led himself, where he compared the beef and the soy burger. So that was just feeding a patty, and saw that the beef burger led to much greater muscle protein synthesis. But if you look at the blood levels of the essential amino acids, they raise much higher, much more pronounced in the beef group. And that's not just work from our lab. There's another nice study from Luc van Loon's lab in Maastricht in the Netherlands, where they compared a whole mixed meal. So they had a beef meal, which was, I think it was a beef steak, some green beans, some potatoes. And they compared that to a vegan meal, which is based on quinoa, edamame, and chickpeas. And they saw the same response with muscle protein synthesis, much more pronounced with the omnivorous meal. And you look at those plasma essential amino acid levels, and they're much higher with the omnivorous meal. So there's something here with the digestibility, the speed of digestibility, and how that acts as a signal for the muscle to turn over. And if we don't see that pronounced response of the blood amino acid levels, then the muscle doesn't receive the signal to the machinery to kick in and to drive that turnover. And the caveat there would be that when we talk about muscle protein synthesis, we're only measuring one half of the equation, because you've got muscle synthesis and you've got breakdown. And breakdown is very, very difficult to measure accurately. So we tend to just focus on synthesis, but it might be that some of these plant-based products are having a different effect on breakdown because of the speed of digestion. That's a question mark at the moment. But what we can say is from the synthesis side that there are certain foods that cause that peak in the plasma essential amino acids, and then that drives the muscle response.
Got it. So it's really all just kind of about how quickly and to what magnitude can you increase blood levels of essential amino acids. The quicker that happens, the better ability to stimulate muscle protein synthesis.
Yeah, I wouldn't say necessarily the quicker, because you could compare a protein shake, which is going to cause it's going to be in and out very quickly. So it's going to cause a very quick spike within the hour, and those essential amino acids be out the blood, versus say a omnivorous meal, which is going to be much more gradual, but it's still going to cause a different peak. So you're looking at like the area under the curve of the essential amino acids, of how much was actually provided to the muscle. And that's an important factor. It's not just a case of speed, but in total, how much substrate can you provide to the muscle?
Right. So area under the curve. But so say theoretically though, if someone were thinking about this practically and they were wanting to ingest protein, as a lot of people do, after a resistance training session, after an endurance exercise session, to expedite recovery, would you look for something that's going to raise essential amino acid levels quicker? I mean, maybe I guess it is also context dependent, because if you raise them quicker, you're going to get that quick spike, but you also sort of want to have this sustained amino acid levels to prolong recovery. I mean, what might be the best practical option there for somebody if they were like looking for the best protein source after exercise?
Oh, that's a great question. I'll try and give a couple of different contexts again. So I think I did a lot of work with combat sport athletes and rugby players in the UK. So these are big, strong athletes, and they eat a lot of protein. Importantly, they're training multiple times a day. So the rugby players will have 2 or 3 training sessions. Combat sport athletes will have 2 or 3 training sessions. Then my answer is going to be very different from that type of person, where I think speed is more important because practically you want something in and out so that it's not sitting in the gut when they do another training session that's going to cause distress, or you take a punch or you take a tackle and it makes you feel sick or unwell. So it becomes more of a practical way to get that protein in, given the demands of the training. For somebody who's training once a day or just a few times a week, I think timing is less relevant, less important for recovery. Once you do that training session, the muscle is sensitized to those amino acids probably for 48, maybe 72 hours afterwards. It's not a case that the muscle needs them in 30 minutes ready to go. I would say it's pragmatic to get something in sooner after training, just because you're probably then going to eat a meal a couple of hours later maybe. But you probably, for most people, unless they're in that group of athletes who are training multiple times a day, I think just getting a high quality protein source is sufficient. You wouldn't need to be worried about the speed that's getting in.
That makes sense. I feel like it's a similar story to muscle glycogen. You know, if you're going to train again the next day, or the same day rather, yes, immediately afterwards to sort of kickstart that glycogen resynthesis. Kind of same thing with protein. It's like as long as you get it throughout the rest of the day, you're going to train again in 24 hours, then you probably don't need to worry about necessarily being so timely about it. But again, as you mentioned, I think pragmatically, why not? Eat a high quality protein source 30 minutes after you work out. It sort of makes sense. A lot of people like to, eat something after they work out. So
yeah, and you asked me at the start how many grams of protein I eat per day. Full disclaimer, my gym bag contains a whey protein shake, and I drink it within 5 minutes of finishing my session. Not because I think that is going to have any specific advantage, but just because I'm probably going to eat a meal an hour later, and it's just a pragmatic way for me to get protein in, and I've done it for so many years. It's just become a habit now.
right. Yeah, I think most people would kind of share that sentiment. So, maybe recognize the anabolic window isn't as important as we once thought, but yeah, if you want to practice it like it is, then sure, that'll work too. So I do want to discuss animal versus plant proteins because I feel like that helps center the discussion a little bit on protein quality, and it's always the topic of a debate. Are animal proteins better? Are plant proteins better? Are plant proteins sufficient? If you can combine them to get all the essential amino acids. So, at the start, maybe we can just say, like, what's higher quality proteins, animal proteins or plant proteins? And then depending on your answer, why is one better than the other and what makes one less high quality than another? We sort of already mentioned this, but
Yeah, and this is, I know it is a plant versus animal discussion, but so we'll try and avoid, hopefully with the paper that came through as well, we're really trying to balance the importance of these 2 protein sources. It's not one or the other, but
for sure.
If we're defining protein quality by the ability to provide those essential amino acids, then animal derived proteins are by and large going to be high quality because they are more digestible and they're more dense. They provide a more dense source of essential amino acids. If we're looking at plant-based sources, there are certain plant-based proteins which can match the ability of those animal sources to provide the essential amino acids. So soy-based products are normally very good. It's in that edamame, tofu, and the plant-based meat alternatives have been processed because they have better digestibility. They can also provide a lot of essential amino acids. Now, as you work towards more what I would call whole food plant protein sources, so haven't gone through the same degree of processing, the digestibility drops and then the essential amino acid density also drops. So if you're looking at protein from grains, from legumes, they can still be very good protein sources, but they might not be sufficient entirely by themselves. A simple way to think about it is if the lower quality protein source or the less bioavailable amino acids that source provides, the greater amount of total protein you need. And that would be my message or caution to people on whatever diet you choose to follow. If you have a diet which is primarily made up from plant-derived proteins, just be aware that you might not be absorbing or have the same degree of bioavailability as somebody who's consuming animal-derived proteins, perfectly fine. You just need more total protein.
Right, and that brings up the concept that you talk about in the review called essential amino acid density. So what is that?
Yeah, so this is based on a portion of food in front of you. What proportion of those calories come from essential amino acids? There's a concept called essential amino acid density. We're not the first people to write about it, and I think it's a useful tool, a practical tool for people to think about in their dietary planning, because it's not so much a case of good versus bad. It's okay, well, what are the foods that are going to provide more essential amino acids? And we've got a figure in the paper, and you can see if you draw a box around the things in the top right corner, which includes plant-based sources as well. If you've got something in your diet each day from that box, then you've got a source of high quality protein. If you don't, then you're going to need to be a little bit more conscious about how you prepare and combine your meals to try and get those same amount of essential amino acids in order to try and support muscle turnover and muscle building as well. And I think, go ahead.
No, that's okay. Keep going.
I think if you're somebody who follows, or most of your protein comes from plant-based sources, but you're very conscientious, you're interested in nutrition, you're really in the weeds of some of this stuff, and you can design a well-structured diet, then you'd be perfectly fine. But many people might transition to a diet which is predominantly plant-based, not without that knowledge, and might have patches or be unaware of the combinations or the things that matter from a protein quality perspective. And I think there can be a knowledge gap between what needs to be done to maximize, again, just protein quality here versus what can happen if you just cut certain food groups out.
Yeah, absolutely. So is that pretty much the idea of these complementary proteins or protein complementation? It's like, obviously, if I'm just eating beans or I'm just eating a piece of whole wheat bread, those are not going to provide me all the essential amino acids. But if I combine beans with rice or maybe bread with peanut butter or something like that, then it's going to provide me with the essential amino acids, similar maybe to a level that I would get eating some sort of animal-based protein.
Yeah, that's right. So legumes, we take beans, black beans as an example. Legumes as a food group tend to be low in the essential amino acid methionine, but they're high in essential amino acid called lysine. If we take a different group now, say grains, so let's take a rice, they tend to be lower in lysine, higher in methionine. So you can start to think, well, we combine those foods together in the same meal and we've got complementary proteins. And again, this is not a new concept. People following plant-based diets, if they're knowledgeable and in the weeds, will be familiar with complementary proteins. And for many cultural diets, it tends to be how we consume. People would have beans with rice, so you've got a natural complement there. One thing to be cautious of is they might provide the amount of essential amino acids you need to meet daily intakes, but they might not necessarily be optimal for muscle building because they're going to be digested more slowly. They're not going to increase their plasma essential amino acid availability to the same extent. And the paper I mentioned from Maastricht from the Netherlands, where they compared the edamame, chickpea, quinoa meal to the beef meal, is a really nice illustration of that concept. So you can use complementary proteins, and that's an important concept. But you would still do well to include some of if your goal is really for muscle building and stimulating muscle protein synthesis, then I'd recommend you have some of the higher quality plant-based protein sources in there. And that's going to include things like the plant-based meat alternatives or plant-based protein isolates.
And regarding the timing, so if you're eating complementary protein sources, do I need to eat those in the same meal? Can I eat, say, beans with lunch and rice for dinner? I mean, I know they often, I think complementary can be used in two ways here, where complementary with the amino acids, but also complementary just in terms of like they make a meal when put together. But just in theory, could I eat beans at lunch and rice at dinner and those are going to create that complementary protein, or does the timing matter? Do I have to eat them actually together? Is there any actually research on that and how that influences their amino acid availability, other protein quality metrics?
Yeah, it's a really good practical question, and I would say we don't have excellent high quality data on that timing of when and how to consume them. What we do have is data using a oxidation technique where we measure amino acids expired in the breath. And if you feed those complementary proteins within the same meal, it improves the retention of those amino acids in the body within a meal. So that's some evidence there that perhaps it matters within a meal. If we're looking at the development of deficiencies over time, well, actually, it seems to be that across a day might be sufficient, or maybe across 2 days might be sufficient. The contention here is we don't have a ready supply of amino acids to release. Like you mentioned glycogen before, we can store carbohydrates as glycogen in the muscle and liver and release them as we need them over 48 hours, or from the liver over 48 hours. We don't have that with essential amino acids. We have the ability to turn over tissues and break down tissues, but we don't really want to have to do that. So it might be that some of the gut tissues can release these essential amino acids if needed, or the muscle tissues can release them. So such that a deficiency wouldn't develop in the short term, but we might then come back to the question of, is that optimal for health and performance? Perhaps not, because we don't want to have to go through the breakdown of those tissues to provide those essential amino acids. So it comes back to what's the focus of the goal. And if you came to me as a predominantly plant-based athlete and said, what's going to be optimal for performance, then based on some of the underpinning theory, I would say within a meal. But if your concern is not optimal performance, I would say across a day might be sufficient.
Yeah, that makes sense. And I mean, I think especially regarding, if you're an athlete or eating after exercise and you're eating kind of predominantly plant-based, it would make sense then to combine those proteins, because I feel like you would be missing out then on an opportunity to stimulate muscle protein synthesis by not combining them versus, say, waiting and eating one at, right after your workout and then one later. Sure, you're eventually going to get all of them, but you're probably not going to have the same magnitude of the muscle protein synthesis response, right?
Yeah, and there's a couple of nice studies, like a proof of concept, where they fed wheat protein as a protein isolate drink after exercise, and see if you were to just give the same amount of protein as you would have in a whey, then you don't get the same stimulation of muscle protein synthesis, because the wheat is a lower quality protein. But if you give more total wheat protein, so I mentioned the relationship between quality and quantity before, if you just ramp up the portion, you can still get a solid muscle protein synthesis response. You just need more total protein. So if you've got a few ways to approach this, you could either think, okay, well, I need my complementary proteins in my post-exercise meal, or I'm going to consume a protein isolate that may be lower in an essential amino acid, but I'm just going to consume a large amount of that protein. Both would probably be sufficient.
Right. And a lot of people, though, are concerned sort of about calories. So it makes sense to get those higher quality ones versus just say, yeah, everybody, you always will see like, oh, people primarily maybe vegan, vegetarian are saying, oh, well, there's a lot of protein in broccoli. There's a lot of protein in chickpeas. Well, yeah, but you have to eat, a couple kilos of broccoli, a couple pounds of broccoli to get the same quality of a protein in a few ounces of steak. So it's really just not that practical to do, I guess, unless you really are just one of these high volume people trying to eat as many whole foods as you can and don't worry about having all the bloating and fiber in your gut. I guess that's okay then.
Yeah, the volume can be an issue. And I think if we start to think about people in the population who have low daily energy needs, and we use the example in the paper of an older sedentary woman who might only need maintenance calories of, say, 1,600 calories a day, then it becomes quite hard to get those essential amino acids from low density sources within your energy limit for maintenance. So for people like you and I who have much higher daily energy needs, that density is usually not so important. But if you only have a ceiling of 1,600 calories, then you need denser, more nutrient-dense sources to make sure you have full coverage across your diet. And it's just trying to think about people with this concept of protein quality. Who are people who need to be more vigilant and aware about this? And that would be an example of someone who I'd say, okay, this is something we need to consider when you're putting your diet together.
Right. If you're eating 3,000, 3,500 calories a day, it's more than likely you're just eventually going to get all your amino acids as well as, all your micronutrients, things like that, because you just have so much, your caloric budget is so high. But that's, I think, a good practical thing for people who may just have a smaller caloric budget. Look for these denser sources so you don't have to, so you can ensure you're getting everything that you need. And unfortunately, it's often the people, maybe older individuals, people who are less active, eating less calories, or probably also maybe eating lower quality protein sources, unfortunately.
Yeah, completely agree.
All right, so one more thing I want to talk about protein quality before maybe we move on to some of our final points, but I want to know how cooking affects the quality of a protein regarding both plant and animal proteins. So cooking animal proteins, does it improve protein quality or does it reduce protein quality? Maybe that differs depending on the animal protein source, but you can tell me.
Yeah, so I'll try and give another couple of specific examples here. If we take a meat, so like a beef steak, for example, or maybe a pork loin, then even in its raw state, it has fairly good digestibility, and it might be that moderate cooking slightly increases that, but it's quite marginal because the animal-derived sources start with high digestibility. One thing to be mindful of is if you cook that food or at really high temperatures, and there's a couple of nice studies where they use grilling, which is very high surface, exposes the food to very high surface temperatures, then we get some conformational changes in the protein within that food that make it harder for our body to digest. So if you're really somebody who, let's say, and I hope there's no one listening who feels this way, but there are lots of people in the world. If you'll say, I like a really well done steak, like really charred, solid, tough as boots, well, that's probably going to reduce the digestibility quite a bit. And we see slower essential amino acid absorption with that overcooking process. And well, some of the research from some of the DIAS studies shows that the actual protein quality score is lower if you overcook the food. And the caveat there is overcooked and subjected to high temperatures, because it's the temperature that causes the change in the protein. But for most people, moderately cooked food, as I'm sure most we cook it, then animal foods are absolutely fine. There is one nice study in eggs comparing raw eggs to cooked eggs, and raw eggs have a much lower digestibility than cooked eggs. So I'm not sure there's any bros or bodybuilders still drinking raw eggs, but if they are, you're far better off cooking them than having them raw.
Yeah, that was a study by Luc Van Loon and some of his colleagues where it was called like, did Rocky get it wrong or right or wrong or something like that. They wanted to test whether slugging raw eggs like Rocky does in some of the movies was actually better. And I thought that was an interesting kind of fun, just proof of concept study that no, don't drink raw eggs. It's better to cook them.
Yeah, that's
Thankfully,
right.
I know I'm not one to really be partial to eating my eggs raw anyway. So
No, that's a good finding. I think everyone's happier to know that you don't need to eat them raw. It's Kaz Fuchs as a lead author on that research, and they did some really nice stuff. Again, looking at muscle protein synthesis response as well in that, which is interesting. So yeah, definitely cook your eggs. You asked about vegetables or plant-based foods as well. And actually, if we take a plant-based food, we take a legume in its raw structure. The nature of a plant-based food is it has much more of a complex food matrix because of the fiber, there's anti-nutrients in there, there's phytates, there's protease inhibitors, which make it harder to break down the proteins. So processing those foods and cooking them actually by and large, tends to improve digestibility. So you can soak, if you're eating legumes, if you soak the legumes, that helps improve digestibility. If you then cook them sort of low and slow and allow that food to break up a little bit, that improves digestibility. As a nice example, again, something we write about in the paper, which is potatoes, where we see a similar effect to meat. So if you expose the potato to a very high prolonged surface temperature, that also seems to decrease digestibility. For most plant-based foods, moderate cooking is going to increase digestibility. And across the board, if you overcook and expose to high surface temperatures, that's probably going to decrease digestibility. Probably the simple take home.
I think that's great. So kind of not across the board, cooking reduces it for animal or plant. Sometimes it depends on the type, but certainly for plants, it seems like cooking it more tends to break down some of these things that lead to poorer digestibility and will probably enhance the amino acid availability of the amino acids in plants, which I think is good. I mean, similar to raw meat, raw eggs, I mean, not a lot of people like to eat raw vegetables. I think it's better cooked with some oil and spices and things like that. So good news, I think, for most people, unless those people want to eat a raw diet, which I don't know many people who do.
No, I think that point about improving digestibility probably matches how most of us prepare food anyway, which is a bonus.
Absolutely. Right. So it seems, I think overall it's pretty agreed upon, animal proteins generally tend to be higher, but plant-based diets, you can meet your essential amino acid needs. Do we? And I mean, I know we do, but I'm curious, maybe your thoughts on them. We have some of these studies that will take people, put them on an animal-based diet, compare them to a plant-based diet, and say then put them through like a resistance training regimen maybe. So now kind of we're talking more about maybe performance compared to health. Do there seem to be major differences in, say, performance outcomes body composition, muscle strength building, kind of any performance outcome that people might be interested in. If you compare, and let's call it a well-balanced plant-based diet versus an animal-based diet, so both contain similar amounts of essential amino acids, both contain similar quantities of protein. Are both of those compatible with building muscle strength? And, do there seem to be major differences between those based on the literature that we have?
So as long as you get sufficient total daily protein, then it probably doesn't matter. The caveat there would be that the studies that have shown equivalence between omnivorous diets and plant-based diets have used what I would call high quality plant-based proteins in their diet, and use that word well structured. So there's a nice study from research group in Exeter where they did just that. They looked at a vegan diet compared with an omnivorous diet, but the vegan diet contained mycoprotein, which is mushroom-derived protein in its whole food form. It's like the Quorn meat alternative product, which is fairly dense in essential amino acids, but they also gave that as a protein isolate, and protein isolates are digested much better than whole food forms as well. So you've still got a protein shake, which is providing a lot of essential amino acids there. And there was a nice whole food study again from Luc van Loon's lab, and he's Jacintha Domic is the lead author, where they looked at whole foods, but they included plant-based meat alternatives. So that included soy yogurts, some of the imitation burgers, imitation sausages. I can't remember the exact products they use, but again, they're in that category of plant-based meat alternatives where the digestibility is better and the essential amino acid content is higher. And that was a shorter term study over a couple of weeks where they looked at muscle protein turnover using doubly labeled water, and they saw no difference between the plant-based, the vegan diet and the omnivorous diet. Just to go back to the Exeter study, they were performing strength training. These are mostly university students engaged in supervised exercise, weights, resistance training. And they saw no change in strength and body composition between the groups. That was the longest study, I think. Can't remember the exact duration, but that ran at least for a couple of months. So at least under those conditions, it doesn't seem to matter so much. And the protein intakes there were above 1.2 grams per kilogram per day. So it's above 1.2 with the inclusion of, at or above 1.2 with the inclusion of some of those higher quality plant-based sources.
Right. And of course, in a lab where these participants are, if it's a study, they're provided sometimes with these foods, and that may not always reflect, what somebody's actually going to eat if they're eating a plant-based diet in training. I'm aware of maybe one more study done here in the States. I think it was maybe at Stanford, where again they did kind of combined aerobic and resistance training, and they compared an animal-based diet to a plant-based diet. But they had the participants eating several. I think at every meal they had some of these plant-based meat alternatives like the Impossible burgers. And so, I'm sure there are people out there eating those at every single meal, but those can be quite expensive. And I'm not sure how well they've been sort of taken up here or anywhere around the world really. But I think it's just in a well-controlled setting, versus what happens in real life. I think we need to note that there may be some differences there.
Yeah, and I think it comes back to the point I made earlier about somebody who's knowledgeable and interested and can design that well-structured diet versus somebody who watches Game Changers and wants to go. I don't know if people are still watching that, but they were watching it a lot 3 or 4 years ago, and then wants to go plant-based. You're immediately cutting out a large section of a whole food group or several food groups. Without that knowledge of how to fill in some of those things you lose from cutting out the groups, then I think you would see some performance or some limitations to performance or muscle turnover. The caveat there is they're doing it poorly and it could be done better.
Absolutely. So one of the quotes that I found and even highlighted in your paper was that protein quality is just one nutritional metric, and a higher quality protein source is not necessarily better for overall health. Instead, food choices must be considered as part of a whole diet alongside other beneficial and potentially harmful components of protein-rich foods. And I like that, Joe, because again, we become hyper-focused on protein. Obviously, your review was focused on protein quality, but we don't just eat protein. We eat foods, and foods whether it's meat, whether it's plants, it contains protein, essential amino acids, but it contains a lot of other things too. We eat whole foods. We're not just eating protein isolates all day long. So, You discuss a few of these things that are in animal proteins and in plant proteins that are kind of part of this food matrix that could either enhance, perhaps sometimes take away from the quality of proteins. Can you discuss what a few of those are and sort of why it's important for people to think about the other compounds, the other nutrients that are contained in food, as well as just protein, and maybe how those things influence the quality of the protein?
Yes, for sure. So you mentioned it, if we make this a plant versus animal comparison, just because it's easier to do so. So I mentioned that on average, the animal proteins will provide more bioavailable essential amino acids. But if you compare that to a plant-based protein source, it's probably going to provide a lot more fiber, which is a whole heap of evidence on the benefits of fiber intake. And maybe that will be, you said the current craze is protein. Maybe the next craze is going to be fiber, because that's something that if most people increased in that diet would be a net positive. But in a lot of the plant-based protein sources, it's actually the fiber is one of the things that decreases the digestibility of the protein. So we're kind of balancing two things here. Most people in the US and in the UK where I'm from would do well to include more plant-based protein sources in their diet, because it would bring something that they're not getting from their other foods. But there are parts of the population who would do well to include more of the animal foods, because they will bring micronutrients and other non-protein nitrogen compounds that are beneficial for health. And just a couple I mentioned in the paper, we have things like taurine, creatine, lysine, are rich in red meats. And we have pretty good evidence that they have some health promoting effects as well. And you're not going to get those compounds from plant-based foods. Likewise, if you prioritize a lot of the animal-sourced foods, you might find you're not getting as much fiber in your diet, or some of the phytonutrients and some of the antioxidants that we'll get from some of the plant-based sources. It's not a case of which one is best. It's okay, well, if you go this route and most is from here, what aren't you getting that you need to be more mindful of? Or if you move more this way, what aren't you getting here that you need to be more mindful of? Because there's no, what the plant-based protein foods might lack in one context, which is the bioavailable essential amino acids. They provide lots of other things that have beneficial effects on health. And that's the kind of point we were trying to make. We don't want people to throw the baby out with the bathwater. It's just be thinking about the combinations of your food and what that is or isn't giving you.
Yeah, it's very practical. I think the creatine was kind of a good example where, if you're a vegan or a vegetarian, you're essentially getting no dietary creatine because it's only found in animal sources. And so there's, I think, a few studies that I'm aware of that just show if you supplement vegans and vegetarians with creatine, it kind of massively improves their physical performance, benefits for cognitive function. It's because they're lacking this nutrient that, creatine, in addition, I mentioned how protein's kind of the craze these days, so is creatine, but all of these health benefits that they're missing out on by not eating animal sources, not because it's the protein, but it's because of the creatine that they're potentially missing out on. So I just thought that was one example, but the micronutrients, the fiber in plant-based foods, I think is a great argument to include those things. I think you're right that fiber is going to become this next nutrient that we're all sort of obsessed with, and not because I feel like fiber had its craze maybe a couple decades ago when everybody thought you needed it to go to the bathroom and it was good for digestive health, whereas now we're realizing it's probably good for nourishing the gut microbiome, short chain fatty acids, and all of these other things. So hopefully we I think after we maybe move past protein, if we ever do, fiber will become the next thing. But it's a very practical way to think about it. I think the way that most people are eating an omnivorous diet. There are people who eat carnivore. There are people who eat plant-based, but, I'm not sure what you do, but I eat meat, I eat vegetables, not too much, probably of either. I just try to have a balanced diet, and we'll give you everything you need generally, as long as you're smart about it. So I liked the idea, and I liked the section of the review where you talked about, we got to think about other things because we don't eat just isolated nutrients. We eat foods, and we know that the food matrix is just so important in influencing how the food and how the different nutrients interact and affect our body and health/performance.
Yeah, and when working with people, I think sometimes the point I like to make is people think some people might think science can tell them what to do. And I would reframe it as I say, science can't tell you what to do, but it can predict what might happen if you do it. In terms of what you do is an entirely personal decision, and I'm not in the business of trying to tell somebody what they should do for what should be a personal decision. But if they come to me and say, here's what I do or here's what I want to do, I can predict some of the issues they might have if they go, or some of the things they need to be more mindful about. So all of the research studies we're doing, we're never producing information to tell people what to do, but just to predict what might happen if you do it.
Man, that's like my favorite quote of the year. I'm gonna have to write that down. I like that a lot. But I mean, it really is a great way to think about science because, I mean, when you think about it, that's when you're reporting the results of a study, you're predicting it with a certain level of confidence, right? You know, that's what p-values and statistics kind of are. It's like we are sure with a, 0.05 level of certainty that this is what's going to happen. And so it won't happen for everybody. And that's why you see individual response curves and graphs, and they sometimes don't align with the averages. So I love that. Yeah, I'm going to put that on a bumper sticker or something and start selling them. All right, Joe. Well, this was a great conversation. I want to ask you one more thing before we go. So I mentioned at the beginning how really, if you take a food, if I go in an aisle in the grocery store and look at a food, I'm going to look on the back and it's going to tell me how many grams of protein. And that's pretty much it. That's pretty much all the information that I get about how much protein is in something. So if you were going to design a food label to better reflect the quality, what type of, or how high quality a source of protein was, what like might you include on that label? So something from like a public health initiative, how would you design your label to reflect the quality of proteins, not just the quantity?
Yeah, it's a great question. And we spoke about this in the department I work in, and David Church I mentioned already. He and I have spoken about this a few times, and I don't know something that would solve problems and really give people transformative information, but I think something we both landed on was having that measure of essential amino acid density. So relative to the calories in this product, what percentage come from essential amino acids? And that's not a perfect solution, but I think it adds something that isn't currently already on a nutrition label. Whereas you have total grams of protein, I wouldn't want to add half a dozen things that are all protein related and it overwhelms people even more. But perhaps something that's essential amino acids relative to the calories, that EAA density marker we mentioned is probably the single thing that I think would be useful.
Yeah. Okay. I love that. Yeah. I think we don't need to go put the PDCAS and the DIAAS on the back of every single thing. I think that would just confuse people more, but I like the idea of putting a protein density score on all packaging. So let's get the people in charge to somehow get that. They're making a lot of changes in the FDA, so maybe we can petition or something.
We'll call them up. Now's the time.
All right, sounds good. I'll call up Robert Kennedy and see what we can get done. All right, Joe, tell people where they can find you. I know you're on X. Or if you're on anywhere else, social media, just let people know maybe where they can follow you, say hey, kind of find more about your work.
Yeah, sure. So I'm on X, Joseph Matthews, and LinkedIn as well, the same. They tend to be the main two social media channels I use. I also have a Substack as well, which is also Joseph Matthews. So find me on one of those platforms and they'll cross-link to each other along.
Great. I will. I'll link all of those here in the show notes so people can just easily find you there. Substack, X, LinkedIn. But yeah, everybody give Joseph a follow. He's great. I'm gonna start to read all of his work after this. This review is the first one I read of his. So thanks again for joining me today, Joe. This was a fun conversation.
Appreciate it. Cheers, Brady.
Yep. Cheers.